All right, practice 4 problem solving number 1. We have a half of a kilogram soccer balls kicked with a force of 12 newtons for 0.2 seconds. The ball was at rest before the kick. What is the speed of the soccer ball after the kick? So what we're going to be looking for is the speed of the ball, and we're always going to talk about the soccer ball. So everything that we do in our diagram is going to be about the soccer ball. So we have a soccer ball, and this is before the kick. So that's the foot. The mass of our soccer ball is going to be half a kilogram, and it was at rest before the kick. So that means at 0.5 kilograms, it was moving at 0 meters per second. Now, during the kick, that means that the ball and the foot have contact, and there's the Newton's third law pair between the ball and the foot, and this is going to be an unbalanced force because the ball there's the force of gravity on the ball, there's the force, a normal force on the ball from the ground, and then there's this force coming from the foot, and it's a normal force because the ball is being kicked by the foot. So it's an unbalanced force, and it's happening at 0.2 seconds with a force of 12 newtons. Now, if you remember from class, this force times time is going to be our impulse. Okay. Now our final, we have the after the ball is kicked, so that means that the foot is no longer touching the ball. So that ball is now flying with a velocity of, we don't know. But it is still 0.5 kilograms. All right, so we know that the ball was being kicked at a force of 12 newtons for 0.2 seconds. And we also know that the mass of the ball is at 0.5 kilograms. And now we're solving for the velocity. We don't know what the velocity is, and we're solving for it. So when we simplify our equation, 0.5, okay, I'm going to just take the units out because some of you said that you were getting confused with it. And so I'll bring it back in. And then we have 12 times 0.2 is going to give us 12 times 0.2 is equal to 0.5 V. So this is 0 plus 12 times 0.2 is going to be 2.4 is equal, oh, wait a minute. Okay, so then 0.5 V, we're going to divide both sides by 0.5, and we have a velocity of 2.4 divided by 0.5 is going to be 4.8 meters per second. So then now we want to also say that the ball is moving at 4.8 meters per second after the kick. Okay, so now going into the proportional reasoning part, we're going to look at the force and time, mass, and velocity. So we know that the ball is moving at 4.8 meters per second. The mass is 0.5 kilograms. It was being kicked for 0.2 seconds at a force of 12 newtons. And now the coefficient, let's see what changed. How fast, so we're still looking for the velocity, so how fast would the ball be traveling if the player kicked with the same force? Same force means that the coefficient is going to be the same with the same ball, so the mass didn't change. but could remain in contact with the ball for 0.6 seconds. So the time changed to 0.6, and we were at 0.2. Now we're going to 0.6, so that means we're multiplying by 3. All right, so then our force stayed the same, our mass stayed the same, but then we see that our time changed to 3. So that means 1 times 3 is equal to 1 times something, which would also equal this other side, so it must be 3. And so since they were asking for the velocity, everything we fill out here is going to be about the velocity. And so then now we are going to look at what 3 times 4.8 is, and that's going to give us 14.4 meters per second. Our written description is going to read, the ball would travel 3 times as fast when kicked with the same force for triple the time. All right, and so that is going to be our number 1 in our packet. Make sure to replay it if you missed something or slow it down. Oh, whoops. I'm glad we took a step back because I want to make sure that we finish our graph over here. So, and then this is going to be the momentum final. All right, that's it.